Hello everyone, this is the week's final reality talk session and we have some very special guests today. We started this session just to be Panasonics, but we have surprise guests for you. We have Jaume Miro, project manager from Panasonic Broadcast Europe. We have Arnaud Cresp, IT manager of Notele, a local TV channel in Belgium. And we have Density's own Vice President of Research and Development, Kuban Altan. And we will get to the bottom of this reality engine and Panasonic's remarkable PTZ camera. And you will hear firsthand insights from the first installment in a local TV channel in Belgium. So to start the session, I will give the word to Jaume to give us an overview of this camera.
So thank you, Birim. Thank you for the invitation to join this webinar, Panasonic and Zero Density together. And yes, I will explain this camera that it's been a kind of revolution for the virtual and augmented reality applications, which is the UE150. So it's the first PTZ camera that provides tracking data. And this is what it makes this camera so unique for these applications. So if we take a look at a bit of the highlights of the camera in the next slide. So this is as I said, this is the first PTZ that provides the data of pan, tilt, zoom, focus in real time. And it does in a synchronized way. So it makes the camera directly compatible with virtual and augmented reality systems. For that development, I mean, our factory, we got the help from Zero Density, and as a result of that, we implemented a protocol which is a standard for this kind of applications, which is 3D. We support both via IP or serial. Typically, we use over IP. And for that, it's a free upgrade in the camera for those customers that already have the camera, but now it's a function that comes included with this camera. We are talking about a 4K camera ready for broadcast because it supports 50p. So it's 2160 by 50p format. At the same time, it has a good balance of zoom and wide angle, so we can use it, say, in both ways. So when the camera is far away, we can use the zoom, but also with this wider angle of view, the camera can be really close to the presenter or really close to the action. I think especially this feature is important for virtual studios, which are typically small. And now, thanks to this new wider angle, we don't need external converters. We can use the camera as it is. The concept of a PTZ is that the camera and the lens and the pan tilt mechanism is all in one body. So the lens is the same, let's say, for all cameras. So we can say that almost all cameras are the same. And thanks to that, it's possible to create a calibration file, as we will see, that makes the installation really simple and easy. The camera is 4K, but at the same time, you can use the HD outputs. So for example, for monitoring, even if you don't have a 4K monitor, it's fine. You can still use the HD. It's really useful for that. The camera, when we say it's 4K completely. So it's 4K with HDR, with BT 2020 color space, and also implementing a logarithmic curve that, as we will see later, it's also very useful for this virtual application. And Kuban, I would like you to explain what are the real benefit of having this tracking data in a Genlock way.
Yes, you actually need to receive the tracking data at every frame that you capture from the video input. So this camera has a very reliable Genlock tracking output as we tested. Yeah.
So, if can we check the, yeah. So this is a PTZ. So one of the the nice functions is to move the camera, of course, to use that functionality. I would say there are 3 ways of controlling the camera. It could be any of these, or it could be the 3 of them at the same time. There, at any time you can use the best method. The first one would be to use the web browser of the camera. The camera comes with a web page, and it's a really nice interface. You can store some presets, and you can have an icon showing what is this preset. So, for example, to store and recall presets, it could be really nice. But now Zero Density also has implemented the control of the camera from the reality control. So I would like Kuban to explain this. But first, let me say that if you need to move the camera on air, you have to do a movement, for example, to follow the action. In that case, I would recommend to have a Panasonic controller like the AW-UE150. Mainly because of the joystick. So with the joystick, you can really perform a really smooth movement, even in live. Also, the panel has a big display, so you can also recall presets from there if it's more convenient. And also, you can control the camera from that panel. So if you prefer having real buttons and a joystick and so on, the Panasonic controller can also be a good help. But as I said, I would like Kuban to explain this latest development on your software and your hardware.
The Reality Control's latest version is going to control the Panasonic PTZ cameras for calling the presets, which are stored previously with the other control tools that you have mentioned. It can be through Web UI or the PTZ controller panel. So we can recall this from Action Builder, Action Control. The use case for this one, maybe I can give an example. Say that you created a zoom out movement to a wide shot using the PTZ, and from the reality control, now you can trigger to that preset camera angle, and at the same time, with a pre-programmed delay in our Action Builder, you can also trigger some other animations and the virtual pull-out camera animation at the same time in the render engine. So this would simplify things when you have to control from the user point of view. You just click on one button and you control both the PTZ camera, the physical PTZ camera, and the engine animations with the virtual camera, virtual 3D camera at the same time. So this is why you need some control interface with one button click for both systems.
Yeah, so let me add that also in the settings of the camera, you can control the speed between presets. So if you want to use this functionality, but also with, for example, with a slow movement, something that you can also control this speed. So the transition from one place to the other, that's also controllable in a speed. Nice function. And I hope you like this picture. For me, it's special because it's also it represents a bit of my experience. When I joined Panasonic, like almost 20 years ago, I remember going to customers and see this strange setup in our pan tilts. As you can see, this is a Panasonic pan tilt, but surrounded by external gears to make them compatible with virtual studios. So this is an example of Technopoint that made this kind of gears so that our panels could be used in those applications. Now, all of this complexity, we are talking that it's inside a PTZ. So as you can imagine, everything, it's much more easier. And for example, if we think in the calibration thing, for example, so the calibration for these old systems, the maintenance that they require, now all of this is just a digital encoder in the cameras, providing, making, I think, the setup, the operation during a long time really, really easy. And I think this is from camera point of view. Of course, we can also think in this, in those cases, we were talking about standard definition. Now we are talking about 4K. So also many other things, but Kuban also from let's say from the keyer, for example, from hardware and software point of view, also during that time, the change is also very big, right?
Yeah, actually people used to have different hardware for renders, for say, for keyers, for compositing and layering. Now it's also very similar in say in this manner also in the rendering and compositing side. Now it's also simple in that side. We just receive the camera signal along with tracking data, and we render, key, and composite all in one computer and output the final image from that one computer. Things got also smaller and simpler in that manner.
Yeah. I think that the result of that is the calibration file. I think that's what clearly shows the benefit of this evolution, right, in the camera. So now you can produce a calibration file, which I understand that it's available for all customers using zero density, and a file that can be loaded, and you can speed up really the installation, right?
Yes, it is actually very easy. It's out of the box. You just select from our lens calibration node, the Panasonic PTZ cameras lens file, and it's ready to operate.
Okay.
Yeah, this is the picture of that. Yeah.
Yeah, so there is also a user guide available to, I mean, the installation, I think it's easier, but also there is this document. I understand that really useful for all customers having this camera and zero density engine. So, but we can, how much time do you think we need for a normal calibration of the cameras now with this?
Without this, it may take, the simplest lenses would be like with not big of a zoom range, say 7 times or something. And if there is not too much distortion and lens breathing, those are the easiest type of lenses to calibrate. It takes a few hours to calibrate. But I know lenses which may require more than 1 day to precisely calibrate because you have more ranges, you have to calibrate more steps, and you have to handle distortions and all the other lens parameters. So it depends, but on the lens type, but it's normally, say, in average, 1 day of work per lens, if it's custom calibrated for that lens.
So I think that thanks to this file, thanks to this quick installation and setup, I think we can, for example, explore things like augmented reality in live events, for example, so that we can set up systems, let's say that temporary, right? So that we can arrive at a place and in a relatively small amount of time, we can have our system running, right? Thanks to this concept of PTZs, calibration file available, and even remote assistance from your side, right?
Yeah, it's definitely easier. Even, for example, for some of the demos we do, we prefer using the Panasonic PTZ camera when we go to a site and make a quick demo. It's very easy to set up and use. We used it many times for our presentations to the clients. When we go on site, we just carry the PTZ, it's out of the box and it just works. So it's very fast to set up.
Okay, so Birim, I think now it's time to Arnaud to confirm what we say
I'm waiting to dive in because we talked a lot about what Reality Engine does with AW-UE150. So let's see a case study on action. If you give me 2 seconds. And so in the background, let this video play and we'll go to Arnaud Cresp to give us insights on the advantages of having this bundle in your local studio and share with us your experience. Arnaud, can you hear us?
Yes. Hi, everybody. Yes, as Birim said, we use the 150 now for more than a year. So I think that there is a lot of advantage to use the new Panasonic camera, but for us there is two that really stand out. The first is the price. Honestly, I don't remember the list price, but for a 4K camera and the tracking system, it's just a revolution. We are a local television. We don't have a big budget like national channels. So this bundle was totally adapted for us. And the second one is the deployment. The tracking is built in. And once you well designed your IT network, it works just fine. The camera remote control, management, the tracking just need one cable, and it's plug and play, as we said, as we seen in the slide. It's plug and play in the Reality Engine. Just have to have the right calibration lens file, and it's okay. And to be honest, as I said in the video, we were very surprised about the tracking quality. Since the video was shot, there was some modification in our sets, as we're now merging a crane with a stipe tracking with two Panasonic PTZ, and it's totally transparent. It's a very satisfying setup.
Nice. For our participants who want to watch the case study video, I will share the link in the chat. But is this all the time you can give to us, Arnaud? I know you're on for a live show soon.
Yes, I'm sorry, but my time slot was very short because we have to prepare a live show. So I wish everybody a good day and see you soon.
Thank you so much for joining us. If there are any specific questions for you, I will send an email, so hopefully you can get back to us.
Yes, no problem.
Thank you.
See you soon.
Merci.
Bye.
So to move on.
Yeah, so we have talked about the camera, but an addition to the camera is this the tuning system, which is there are different configurations as you can see here. So it's a combination of dollies and columns, especially for the Panasonic PTZ cameras, and it provides, as you can easily understand two additional axes of movement, horizontal and or vertical. And it provides really spectacular images. So it's not only the quality of the UE150 as a PTZ, but this concept of moving the camera around, it produces a change in the perspective that you can play a bit more with your virtuality, with either virtual objects or with your background. So it's a system made for this kind of cameras. It's in line with our cameras, also, let's say, in terms of the investment and so on. It's a good addition. It could be a combination of, let's say, a standalone PTZ cameras, as we saw in the Notele camera on a tripod, but for example, having one central camera on a floor dolly or ceiling dolly could add this beauty shot to your production that it's a really nice picture, something that you cannot get with just the PTZ movement. And the good thing of this system is that because it's fully integrated with the UE150 camera, is that it takes the tracking data from the camera, it combines with the tracking data horizontally or vertically. So it takes the data from the dolly or from the column. It combines both data and it delivers one single stream to, for example, to the reality engine of zero density. So from zero density point of view, we don't lose this integration. It's still one single stream, still everything, let's say, calibrated and quite easy to set up, right? I think, Kuban, also you had this system for test, and there have been also some tests in some of your customers, right?
Yeah, I guess KST has set this up and even tested. I heard it in Germany. And we have one unit in our R&D studio, and we are working on this as well on our R&D studio.
Yeah, here there is a couple of links that you can see an example of augmented reality in YouTube. You will see some virtual objects, and you can easily understand how this horizontal movement in that case is really creating these nice beauty shots. Yeah.
We had a couple of questions regarding the rigs and rails for this PTZ camera, but I consider them answered. So if you have any detailed questions, please add new ones. Well, I'm moving on.
The control of, yeah, well, as I said, it's an integrated system. So basically the control of this is, again, well, you can use the controller or you can create some movements. There is a software for that, software interface for that. And then you can, so when you create a movement, all the axes, pan, tilt, zoom, focus of the camera, plus horizontal and vertical of the dolly and totem, everything is synchronized. So there is a timeline, you define the time. It's, normally you create some keyframes during the way, so start position, middle position, end position, for example, 3 keyframes. You define a time between keyframes or a total time. And from operation point of view, you will just click one button, and you can click or you can recall this, you can trigger this button from zero density through an IP command. So this is why this system is integrated with Panasonic, because it understands the Panasonic protocol. So it's not the camera on one side doing one movement and the dolly on another. No, it's everything is synchronized. So from it's a continuous movement and always smooth and always in sync. I think we are getting not only because of the situation, but of course with the current situation also more and more. But I think this situation of having cameras in one place, and the control and maybe also the reality engine in another place, right? It could be different studios or different buildings or different cities or even different customers, you know? So for example, I'm just putting here an example. Let's imagine a connection between Los Angeles and Connecticut, camera in one place and the engine in another. And this is more and more becoming possible. And I would like you, Kuban, to explain how zero density can facilitate that, that remote production in order to avoid issues with the network.
Yes. Usually also on the slide, I would like to add on the Los Angeles side, think that you have a green screen cyclorama like this, right? And you're shooting some person in front of the green cyclorama. But then you have to transmit that video, audio, and tracking data through the wide area network to the studio in Connecticut, for example. The thing is, of course, there are many devices which transmit STI streams over the internet by compressing the stream, and we know all those available equipment. But the tracking data is usually sent over UDP on the internet. But usually, people set up VPNs between those two sites. And since the packages are UDP, if you use a VPN, which goes through a TCP tunnel, actually all the UDP packets need to be delivered to the other side of the VPN. Because there's a TCP tunnel, there's not any risk like losing UDP packets over wide area network when you utilize a TCP tunneling VPN. So, but the thing is, you will introduce different network timing jitters for the tracking data. Since you are on a wide area network, every package will have a different delay on such a use case. But since there is no packet loss on a TCP-based VPN tunnel, everything will work fine, since our engine can ring buffer also the tracking data. So our engine has been designed to work with ring buffers for the rendering of the images, as well as having the compatible buffering for the tracking data. So the network timing jitter through wide area network is not an issue, as we are not using the tracking data with a real-time delay. We are queuing them along with every frame that comes through the video stream.
Okay, that's good, because I think you agree, right, that this is a kind of trend for now and also for the future. I think we have to think more and more in this direction, and I understand that from what you say, that also your developments go in this direction to make your software and your system more stable, no? more robust, considering all the delays and all the things of using this remote connection. But I think it's good that you are working in this direction too, because clearly this is what now it's becoming a reality, right?
Yes, people require, our users require this kind of features, especially these days. So we are concentrating on what our users need and prioritize all those features and stabilities during these days in development.
Good. So if we change a little bit the topic, if we talk also about how do you take the signal from the camera. I mentioned in the introduction that the UE150 has also implemented the logarithmic curve that we, as Panasonic, we had created for our cinema cameras, like the Varicam, which you also support. Of course, initially the idea of this logarithmic curve is mainly for these cinema look applications, but now this also has become a way of improve the quality on your gear, because you take that signal, which is, let's say, more pure, and you can process in a better way, and let's say with a better result in the output, right?
Especially with the help of the UHD resolution as well. For example, even if our user doesn't broadcast in UHD resolution, we can still capture in UHD resolution. So we have a higher resolution as the input in vlog. So we can first linearize the log image and keep all the highlights without clipping them. Unlike my poor webcam, the highlights are clipped, but on the vlog camera, the signal is HDR, so you still have a lot of highlight detail. And we capture also the highlight details available from the camera and go through the reality keyer, which can work with HDR images as well. And then what we do, we process the Ultra HD, HDR image, then we downscale it to HD resolution if the user needs to have HD composite, and the HD image is projected into the Unreal scene. So the Unreal scene is also rendered in HD, but Unreal Engine is an HDR renderer. It can also make use of HDR images that we project into the scene. So even if the highlight details are not visible, just like on my face, lots of whites are getting clipped. If I receive a lot of light, say that I have a transparent surface in the virtual scene. Maybe I can simulate that on my webcam. My highlights get clipped, but yeah, it's still transparent. No, it's reflecting. I can't show it. But think that this surface is, say, CGI, and it's lowering my exposure. Then I will see my details in my face in the renderer. Say that I have a reflection in the scene, which is on a dark surface. So I have darker reflections. Then I will see the details in there too during rendering. So all those highlight details, even if you are not broadcasting in HDR, even if you just create a regular Rec 709 output, and even if you don't broadcast in UHD resolution, having a UHD input, keying it in that resolution, keeping the HDR highlights and downscaling to HD and rendering with a HDR renderer, then outputting to Rec 709 HD streams will improve the visual fidelity of the rendering and the composite. I'm really a strong fan of high resolution video cameras with HDR images.
So then we can conclude that it is it's indeed a good idea, right? To work in 4K, even if our broadcasting cannot be 4K, or we don't see when it can be 4K, but clearly there is a benefit in the final output, right? So also I would say that from investment point of view, I think it's also now makes sense to invest in cameras that they have a 4K capability. So this is also the trend also in Panasonic. So I would say that 90 or more % of our cameras are already 4K. So you want it or not, you have it in your camera. So, but I understand that the benefit of your gear in 4K, it clearly brings benefits in the output, right?
It is 4 times oversampling. It's very easy. You have 4 times the pixels, and for creating each HD pixel, we sample 4 UHD pixels, then use those 4 samples to downscale to HD. So this really helps with the keying noise and all the spill and spill suppressor noise as well.
Okay, good. So I think we have covered all the topics. I don't know, maybe we could check some questions, Birim?
Yes, we have a lot incoming questions. So
That's
we
good.
did some of them, you know, in the flow, but just to come back to them for concluding. So is there a special rig or gimbal which is compatible with the PTZ camera? And in this case, will it still sending the tracking data to reality?
Yeah, well, for us, this is the system I explained. It's called Tuning. It's available through Panasonic. So it's it's a system that we are providing as Panasonic because, as I said, it's optimized, it's developed for the Panasonic PTZ, not only because mechanically it fits the camera. No, it's more deeply. It's about the protocol that it's using. So it's based in the protocol of the Panasonic cameras. That's why the movements can be synchronized, and also this is why the tracking data from the camera combines with the data from the dolly or from the column, and it delivers to your engine. So it's a system that it's available as Panasonic, and this is the one that we recommend. There are different configurations. So it could be I showed some pictures. It could be just the dolly. It could be just a column, so a vertical movement. It could be both, and it could be on the floor, or it could be hanging from the ceiling. So there are different configurations available for that.
Great. So maybe this one to Kuban. Was the lens file that comes with the Panasonic camera done by Zero Density or by Panasonic?
It has been created by one of our support engineers who usually does the calibrations for our clients on site. We have calibrated it in our R&D studio by the Zero Density support engineering team.
Super. So back to Jaume, is there a new version this year of the UE150 or same model as last year?
It's same model. As I said, this is, I mean, if you purchase the camera now, the function it's there. But for customers that maybe purchased the camera 1 year ago, then it's just a free upgrade in our support website. So I think the minimum version is 2.16, but now we are in the version 2.30 or something like that. So it was at least 1 year ago. So any customer can, in those cases, they can upgrade the camera, and they will find in the settings in the web browser, they will find the setting of the tracking data. Basically, it's quite easy. You just have to enable, to select IP or serial. And if you use IP, then you can enter up to 4 destinations to deliver the tracking data. So in theory, we need only 1, but in case you have to deliver to several machines, up to 4 can be entered in the web menu.
Okay, so we can use live view. Can we use live view with IP pipe? I don't know what this means.
I mean, the question here is this. I understand that we are talking about wireless transmission. I understand live view with bonding and so on. The thing is about the gen log. I mean, transmitting the data is not a problem because it's on the IP channel, so that's not a problem. It's more about the synchronization of both things on the camera and on your engine. But this is more or less what I think we covered. I'm not sure, Kuban, what do you think in this case?
About live view, we are talking about the video image or the tracking?
They can transmit, now it's possible to transmit both video, and there is one channel for a kind of Ethernet channel now in the transmission. So you can transmit video and the Ethernet. So for a PTZ, it makes sense because you can control the camera. Also, the 3D will be there. The only thing is to genlock the camera and the...
I haven't used live view myself. I haven't tested that, but I know the product. I heard. What I can answer is just in theory. If you want to genlock your studio cameras and one camera or one video feed that has been broadcast through live view transmitted to your studio, the genlocks should be, say, synchronized to the GPS network via satellite. You can do that. Otherwise, what you have to do is you have to use a frame synchronizer. But I don't know live view's feature. Maybe it can even frame synchronize on the receiving side as an option if you genlock it. It should be like that, I guess. If that repeats the Ethernet package as well, when you repeat a frame or skip a frame, it should work, but that's something that needs to be specifically tested. But what I think is if you create the same GAN locking setup on both sides, if they're GAN locked both to the GPS satellite signal, there shouldn't be any frame count difference between two sites. Then there is no frame drops or skips involved. That should work actually in theory. But the other thing, if you need to frame synchronize, if you don't provide GAN locking with the satellite signal coming from the GPS network, then I don't know. I need to test with the live view equipment, which we don't have for now. But obviously, we should have a lot in the future because this is requested a lot.
Yeah.
Okay. Is there any prompter system that can move in synchronization with the panel tilt movement of the PTZ camera in studios?
Yes, there is. Honestly, I can't tell you now the name, but yeah, we have had in our, for example, in our booth at NAV last year. So it's a special prompter for these PTZs. So yeah, see, somebody is putting the name on the chat. So it's it exists. So it's made for the PTZ, so they can move at the same time. It's true that many customers are using just a normal prompter and very limited movement of the pan and tilt. That's true, but it exists. I see some answers in the chat because sorry, but I was not remembering the name. But it's an external solution. It's not Panasonic, but we have demonstrated, and there are pictures and case studies for that. Yeah.
Okay, thank you. So there's another question regarding the compatibility of Panasonic PTZ tracking protocol with other VR AR solutions.
Yes, I mean, yeah, this is. I mean, we are today with zero density, and we are happy to be with you. But of course, the 3D is a standard protocol in the market for that, so it makes the camera compatible with any other graphics system in the market that you all know. The point here is what I would like to say is, one thing is the tracking data. This is compatible with any system, I think. Another thing is if other systems can deliver this calibration file or not. Most of them, I think they can do this because it's the same concept. And another thing is to take a look at these functionalities, these added values that, for example, every one of these solutions can bring. So, for example, in case of zero density, I would say this control of as we explained at the beginning, this control of the camera from your engine makes the operation really simple, because in one button you control both the camera and the virtuality. So this is because, in addition to the 3D, zero density has implemented also the Panasonic protocol in terms of control of the camera. And also for zero density, the V-lock acquisition, I think this is something, let's say, unique, that at the end is, but then we talk mainly in this case about the quality of the key, right?
Yes. So there is a little bit of confusion about the lens calibration. So do we need to send the camera back to zero density if we replace the camera for the lens calibration, is the question.
No. No. Well, maybe Kuban, you can answer better, but my understanding is, yeah, somebody asked before, the calibration file is not made by Panasonic. We have worked together with zero density, for example. We have provided the data of where is the sensor, for example, where some values, let's say, internally of the camera, but the calibration file is produced by you, and I think it's available through you, right?
Yes, it's available with our distribution of Reality Engine. So basically, it all depends on the manufacturing quality of the camera and the lens. If we just calibrated the unit that we had in our R&D, and since the Panasonic can reproduce the same camera with very similar settings with their lenses every time they produce, the calibration file works very okay with every other Panasonic PTZ UE150 we see. So far, we have never required a custom calibration for one Panasonic PTZ. The one thing that I could hear that something will require that, maybe a damaged camera or something. If you hit the lens physically to somewhere, maybe you have a broken lens or something, a little bit shifted, then you may need to require that. But so far, we haven't seen any. I haven't heard from our support team.
Yeah. So we answered almost all of the questions. So I think we're in the wrapping up section. If there are any other questions, let's flow them in now so we can answer and conclude today's session. In the meantime, there is also this tracking protocol thing attracts a lot of questions. So one participant asks, if we use UE150, but we don't have the tuning, we have another tracking equipment that provides the XYZ data. Can zero density accept this combination?
I guess this is a question for me, Jaume.
Yes.
Okay.
True. Sorry.
So say that you have another tracking system that is also gen locked. What you have to do is say that it is also sending a 3D protocol tracking data. You just receive on the reality side, reality engine side, both of the tracking streams. What you can do is in our node-based processing system, you can split the tracking data into two and combine the PTZ data coming from one feed with the other one. This, in theory, this should work. I have heard also some of our clients have done such things previously. So looking to those transform data, the XYZ in our node-based system, you should break the rotation data, get the rotation data from the Panasonic PTZ, also the FOV and lens calibration parameters. Only the transform needs to be the XYZ location should be received from another device. Say that this is a theoretical question, right? I have to see the specific device and the protocol that it works correctly, but in theory it should work.
Let me just say something. I cannot say too much, but I would say to the people to take a look at in the following weeks. They will hear something from Moses, from Trackman. So they are working on that. So they will, I mean, this is two examples of companies providing tracking systems that they will take the data from the camera, from the UE150, they will combine with their systems and they will provide, again, a unique tracking stream. So I mean, they are also very interested in this camera. So in a matter of, let's say, in a very short time, you will not have to deliver two streams differently. So at least for some of them, it will be possible to have in one stream all the data. And it means that it will be possible to move the camera around in the studio, for example. So you can put the camera and move because it will be all the time calibrated. But I cannot say more than that.
This is good enough.
It's good enough just to motivate people
it gives the idea. Yeah.
to take a look in the coming weeks to the announcements. But this is, I think this is also bringing more possibilities because, for example, this possibility of moving the camera around in the studio gives a lot of, let's say, freedom, right? So now maybe the problem that is that we do this calibration initially with the camera on a tripod, but if our tripod is somebody moves a little bit, we lost the calibration, right? But adding these tracking systems, we can be more flexible in that. So we can move the camera or we can avoid this accident. So it's something that we want also to talk about this topic in the following weeks.
Okay, thank you so much. I think we have a bit more questions, very detailed, so I will get back to those participants after the session with some digging into. But if you have any closing remarks for today's session? Kuban, can we start with you?
What kind of things do you expect?
Closing remarks. We're concluding our session.
Okay. How can I conclude? Yeah, the Panasonic PTZ is the first tracking integrated PTZ camera that we have worked with Panasonic and that we are very happy with. So it's very nice that people have adopted both our engine and the PTZ camera from Panasonic that it's being used in production. And we just want to grow this community because we know that it works and it's easy to set up.
Yeah, from my side, I would say, well, the camera, I think it's a good camera, but what I'm, for me, the message is that for customers, is like that I would like them to see that this webinar is an example of the collaboration between these two companies that started really from the beginning when this camera was under development at factory. So what I mean is we are in permanent contact. So trying always to find new ways of deep integration, like the control, like the vlog for the quality, and or to solve any issues that customers may have. So I would like to say that you know, we are different companies, of course, but we are really collaborating, working together. We are almost talking every week. So any customer, for example, having an issue with the calibration file, with the camera, we either from Zero Density or from Panasonic, I think we can easily help in a way that we together support these customers. So it's not only this webinar, it's not only that, it's really a collaboration that is been going on from the beginning, and I think it's continuing, and you will see more and more integration, I think, for in the future.